Welcome back, everyone. So today we're going to be talking about statistics. And what that is statistics is just we're given a set of data and we want to find out specific characteristics about that data based on values that we find about the data. Okay? And so if we're given a set of data, we can measure two things. We can measure what we call measures of center, where we look at a central value and tell some things about the set of data, or we can measure spread, which we'll get into a little bit later in this lesson. Okay, and so the first thing I want to talk about is how to find the mean or the average of a set of values that we're given. Okay, and so for example, let's say we have that this set of data points represents the number of text messages Isaac receives each day for a week. Okay, so on the first day he receives 47 text messages, 49 on day 2, 54 on day 3, etc. All right, and we want to find the mean for these. So what we're going to do, the mean is the sum of these values divided by the number of values actually in the set. Okay, and so to find the mean, let's just grab our pen. To find the mean, we're gonna do exactly that. We're gonna take the sum of the numbers okay, and we're gonna divide these numbers by the number of values in the set, which is 3, 6, 7. Okay, and so when we do that, we get a sum of 350 divided by 7, and so our mean is 50. And so what this tells us is that on a daily basis, he gets an average number of 50 text messages per day, which is really close. If you look at our set of data, that's a good mean because all of these numbers are really close to 50. Okay. Secondly, what I wanted to another measure of center that we want to talk about is the median. And the median is the middle value in a set when values are arranged in a particular order. Okay, so we're looking at the same set of data for Isaac, the number of text messages that he receives each day for a week. And now we want to find the median for this set of values. Okay, and so what we want to do is we want to pay attention to that it needs to be in numerical order. Okay, that is very important when you're finding the median. When you're finding the average, it doesn't matter if it's in order, but when you're finding the median, it does. Okay, and so we're going to write these in order. So we have 47, 47, 48, 49, 50, 54, and 55. And so I'm just going to double check that I still have 7 values. 3, 6, 7. Okay, and so what we want to do when we find the median is that we want to find what our central value is. So what I like to do is I chop off one number from each end. Okay, and so we go here, 1. Okay, here, and here. And so our median value is 49. So here our median value would be 49. Okay, and so what the median value is another central value that tells you, this roughly tells you that he receives 49 text messages daily, which is not too far off from our mean or our average. Okay, so let's look at another example. We want to find the mean and the median for this average, for this set of values. All right, and so what's represented here is the amount of money Elise earns in tips per day for 6 days, 6 days a week. Okay, and so again, to find the mean, we want to take the sum of these values. So 75, 97, 360, 84, 119, and 100. And we want to divide that by the number of values here, which is 6. Okay, and so if we take the sum of these numbers, we get a sum of 835, and we want to divide that by 6. Okay, and so we get roughly or approximately that the mean amount of money that Elise earns per day is going to be roughly $139.17. Okay, and so now we want to find the median for this same set of data. Okay, and so the median, remember, we want to place our numbers in numerical order. So we have 75, 84, 97, 100, 119, and 360. Okay, and again, I'm going to chop off one number from each end. So 75 and 360, 84 and 119. And notice now with this set of data that we have two numbers left over. As before in our previous set of data, we only had one number. Okay? And so here, whenever you have a situation where you have two numbers that are left over when you're finding your median, what you're going to do is you're going to take the mean or the average of these two numbers. So we want to take the average of 97 and 100. Okay, and so that's 197 over 2, which gives us roughly 98.5. Okay, and so what this tells us is that she makes roughly $98.50 daily as her tips. And so when we're looking at this set of data, we see that our mean and our median are far apart. One we get 139.17, and the other we get $98.50. And so you can see that because in our data points, the values are spread far across. They're not really close together as they were in our last example. Okay. And so the next topic, the next thing that I want to go into is the measures of spread. So we have the measures of center, which are your mean or your average and your median. And now we have the measures of spread. And so what the measures of spread does is that it looks at the whole data set and how far the values are apart from each other. Okay, and so the first thing we want to talk about is the range. And the range is the difference between the greatest and the least data values. So you want to, when we're talking about measures of spread, we also want to put our set of data or our data values in numerical order. Okay, and the next thing that I want to talk about is your quartiles. So quartiles are values that divide a set into 4 equal parts. Okay, and so the easiest quartile to get is the second quartile because that's the actual median value, which we found in the previous two examples. Okay, so you put your numbers in numerical order, and then you chop off one number from each end until you find your actual median value. Now, once you find this actual median value, which is your second quartile, or denoted as Q sub 2, then you want to find your first quartile. And your first quartile, denoted Q1, is the median of that lower half of data. And we're going to look at an example in just a moment to see how we actually do this. But I want to just go through the actual vocabulary that we need to know before we start looking at an example. Okay? And your third quartile, denoted Q sub 3, is the median of the upper half. So your second quartile divides your data set into by its median, and then you want to find the median of the first quartile, which is the lower half. The third quartile is the median of the upper half, and then lastly we have our interquartile range, or denoted IQR, which is the difference between the value that you get for Q sub 3 and the value that you get for Q sub 1. Okay, so now let's look at an example of how we actually find these values. Okay, so we have this set of data 1, 2, 2, 3, 3, 4, 4, 5, 6, 6, 7, 7, 8, 8, and 9. And we want to find the following measures of spread. We want to find the range. We want to find the value for the first quartile, second quartile, and the third quartile, and the interquartile range. Okay, so the first thing that we're going to do, we see that our numbers are already in numerical order. If they aren't in numerical order, then put them in numerical order first before you proceed to find these values. Okay, and so the range is simply our the greatest value that we have minus our smallest value. So our range is going to be 9 minus 1, which is 8. Okay, now remember I stated that that the easiest value to find when we're talking about our quartiles is Q2, because that's simply our median. Okay, so when we find our median, I'm going to choose a different color. Remember, we knock one value off from each end. So I'm going to knock this value off, one here, okay, and we see that our median is 5. So this is our median value. So our median value is 5, which is also our quartile 2 value. Okay, now here, this lower set of data, so let's erase these marks off of here. Okay, and also on this side, now that we found our median. Okay, so this lower set of data right here is our lower range, or our lower quartile. And we want to find the median of that to find quartile 1. So to find the median of that using quartile 1, we just do the same thing over. Knock one off from each end. And so we get that Q1 would be 3. And now we want to do the same thing for this set of data over here. This is our upper quartile. Okay, so we knock one off from each end. And we see that our value is going to be 7. Okay, and so remember, our interquartile range is simply just Q sub 3 minus Q sub 1, or our third quartile minus our first quartile. So we're actually going to have a value of 7 minus 3, which is 4. Okay, and so that's how you find your measures of spread for a set of data. All right, and the last thing that I want to talk about is standard deviation. Okay, this is our another measure of spread, but this is a more exact measure of spread, because what it does is it tells you the average distance between an individual data value and its actual mean. Okay, and so we have an actual formula for finding standard deviation, which is the square root of the sum of the deviation squared over the number of data values. Okay, so let's actually look at a set of data values. So we have 122, 139, and 189, and we want to find the standard deviation for these values to the nearest 10. Okay, so the first thing that we're going to do is we're going to find the mean of these values. Okay, and so the mean is just 122 plus 139 plus 189 over 3. Okay, and so when we do that, we get a mean of 150. Okay, and so we get a mean of 150. So the first thing we want to do is we want to find the mean of these values. Okay, second thing we want to do is that we want to find the deviation from these means. So to find the deviation from these means, we're simply going to take the value itself and we're going to subtract from it the actual mean. Okay, and so our mean is going to be represented by X bar. Okay, so let's find those values. So we're going to have 122 minus 150, which is negative 18. We're going to have 139 minus 150, which is negative 11. And then we're going to have 189 minus 150, which is 39. Okay, so we found the deviation from the mean, which is the distance between the actual data value and the average value or the mean value. And now we want to square those. So if we square negative 18, we get a value of 324. Square negative 11, we get a value of 121. And square a value 39, we get 1521. Okay, and so lastly, what we want to do is we want to find the mean. So we found the deviation from the mean, and so this represents our squared deviation. So now we want to find the average of those squared deviations. Okay, so to take the average of the squared deviations, which is x minus x bar squared, we do 324 plus 121. Okay, and so let's extend this. 324 plus 121 plus 1521 divided by 3. And so we get a value of approximately 655.3 repeating. And now finally we want to take, according to our formula, we want to take the square root of that number. Okay, so if we take the square root of that number, we want the square root of 655.3 repeating. We get that value of approximately 25.6. And so one thing that I want to mention is that when you look at standard deviation is denoted with the Greek letter, the lowercase Greek letter sigma. Okay? So standard deviation is denoted by the lower Greek letter sigma. And so our standard deviation for this set of data is 25.6. Okay? And that is the end of today's lesson.